Hello everyone, this is Abhishek Virmani from Next Wave Abroad. Today we are going to cover our next topic of algebra, that is exponents and roots. So let us start with the session. Exponents and roots are one of the important concepts of algebra, wherein the powers are raised to a base. There are certain rules that are to be followed for this particular expression. Exponents and powers basically fall into the second position of the PEMDAS. So if we learn the acronym PEMDAS, P stands for parentheses, which are brackets. E stands for exponents. M stands for multiplication. D stands for division. A stands for addition. And S stands for subtraction. Exponents are also basically the repeated multiplication. So if you have 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, you can simply write down it as 2 raised to power 5, where 2 will be the base, and because it is multiplied 5 times, we will write it down as 2 raised to power 5. Now let us see the rules that we need to follow. The first and the most important rule is anything raised to power 0 is equal to 1. I have mentioned it as A, but you need to consider it as anything. It would be anything and everything. Anything raised to power 0, it will be equal to 1. The second rule is if the bases are same and we raise the power to m, and again we have a raised to power n. So basically the sign of multiplication is there in between. The powers gets added with the same base. So a raised to power n divided by a raised to power n would be a raised to power m minus n. So powers get subtracted in case of division if the bases are same. For a raised to power m into b raised to power m, here the bases are different but the powers are same. Then we can multiply the bases together and then raise to the power. So ab whole raised to power m. Same goes with division also. If the powers are same, a raised to power m divided by b raised to power m, we will get a divided by b whole raised to power m. And with the negative powers, we have to take the reciprocal of the base. So we can change the sign of the power by taking reciprocal of the base. And the last rule is a raised to power m whole raised to power n will give you a raised to power m into n. Now, these rules are applicable for any powers. And now when we say any powers, it may be integers, it may be fractionals also. So for fractional powers, there is another symbol that is in common use. That is the symbol of root. So if we have nth root, it is expressed in this format. And nth root means raised to power 1 upon n. So basically, a raised to power m upon n means n is the fractional power. So that is why we can write it down as a raised to power m whole raised to power m 1 upon n, or a raised to power 1 upon n whole raised to power m, or nth root of a raised to power m, or nth root of a whole raised to power m. For square root, we can simply write down this symbol, square root of a. And for cube root, we can write it down as this. Remember that as the base increases for a raised to power n, as base increases if a is greater than 0, the and as power increases, the value also increases. For a less than 0, as the power increases, value decreases. For example, if a is 2, if you raise the power 2 raised to power 1, would be less than 2 raised to power 2, would be less than 2 raised to power 3, and so on. Similarly, if you take a as 1 upon 2, that means a is less than 1. So basically, it's not less than 0, but it is less than 1. If a is less than 1, Then as you raise the power, the value decreases. So this would be greater than 1 upon 2 whole square would be greater than 1 upon 2 whole cube, and so on. Remember that there are no identities for addition or subtraction. There are no identities for addition or subtraction. Let us now move to the next thing and see how the questions for this particular topic are asked in GRE. The question is, what is the greatest prime factor of 2 raised to power 99 minus 2 raised to power 96? As we do not have any formula for addition or subtraction in exponents, we can simply take 2 raised to power 96, that is the lower power can be taken out common, and we will be left with 2 raised to power 3 minus 1, which can be written as 2 raised to power 96 into 8 minus 1, which is 7. So you can see that 7 is the greatest prime factor that this particular expression can have. So that would be your answer. Let us see the next one. 17 into m raised to power 1 upon 3 is equal to 34. So you can say m raised to 1 upon 3 is equal to 2. That means m would be equal to 8 if I cube both the sides. Now putting the value of m as 8, I can find the value of this expression. 4 into, we have 8 raised to power 8 whole raised to power 1 upon 6. This can further be written as 4 into 2 raised to power 3 whole raised to power 8 and whole raised to power 1 upon 6. We can reduce the number into lowest base. So 4 multiplied by 2 raised to power 24 upon 6, which is 4 into 2 raised to power 4, which is nothing but 4 into 16, and the answer would be 64. Let us see, and yes, we got the correct answer. Let us move to the next question. 216 is equal to 2 raised to power x into 3 raised to power y. So the first thing that you should do is just break it down 216 and express in the basis of 2 and 3. So 2, 108, 2, 54, 2, 27, 3, 9, 3, 3, and then 3, 1. So that means 216 can be written as 2 raised to power 3 into 3 raised to power 3. Just comparing the bases and the powers, we get x as 3 and y as 3, which means both quantities a and b are equal, and therefore the answer would be C. So we got the correct answer. Let us see the next question. It says if 12 raised to power x is odd, so 12 raised to power x is odd. This is only possible if x is 0. Because if x is other than 0, because 12 has a unit digit 2, any power of 12 other than 0 will give you an even number. Therefore, x is 0, so that 12 raised to power 0 will come out to be 1. Now, because x is 0, the value of x raised to power 12, that is 0 raised to power 12, would be 0. So, quantity A is 0. Now, let us find quantity B. It says 2 raised to power k is common from each term. This would be 1 minus 2 raised to power 1 plus 2 raised to power minus 1, that can be written as 1 upon 2. This will be equal to 2 raised to power k into m. So 2 raised to power k and 2 raised to power k gets cancelled out. We are left with m equals to negative 1 upon 2. You can see that quantity A would be greater, and that is why the answer is A. Let us now move to the next question. It says 2 upon 9 into 81 raised to power 50, which can be written as 2 upon 9 into 9 raised to power 2 whole raised to power 50, which can be written as 2 upon 9 into 9 raised to power 100, which can further be written as 2 into 9 raised to power 99. Now you can see that in the second thing, that is quantity B, we have 9 upon 2 into 9 raised to power 99, which can be written as 4.5 multiplied by 9 raised to power 99. So if I just compare the two quantities, in quantity A, the 9, the power of 9, that is 9 raised to 199 is multiplied by 2. And in quantity B, 9 raised to 199 is multiplied by 4.5. Definitely quantity B would be greater, and therefore the answer would be B. I hope it's clear for everyone. Great. Let us try the next question. It says 5 raised to power 7 plus 5, that is 5 raised to power 11 is equal to 5 raised to power minus 8. We can say that A would be equal to minus 11 by comparing the powers as the bases are same. In the next one, 2 raised to a minus 3 minus minus 2, that means minus 3 plus 2. So 2 raised to a minus 1 is equal to 2 raised to power 2b. I have written 4 as 2 raised to power 2. So that means 2b is equal to minus 1, which gives me b is equal to minus 1 upon 2. So this is your b. And then 3 raised to power 9 is equal to 3 raised to power 3c. I have written 27 as 3 raised to power 3. So that means your c would be equal to 3. Thus comparing the powers as the bases are same. Now I need to find the value of a, which is minus 11 plus 4 into b, that is 4 into minus 1 upon 2 minus c. So that would be minus 11 minus 2 minus 3. The final answer would be minus 16. And yes, we have minus 16 in the options. So C would be the correct answer. So that was a pretty simple chapter. Exponents and roots is an important topic of algebra, and you get its application in almost all the chapters. May it be functions, may it be graphs, may it be word problems. So definitely you can use these rules and try to gauge the expertise in this chapter considering its easiness. And in case you still have any doubts, definitely please reach out to us and let us know your query. We will be uh, grateful to resolve your doubts. Thank you. Have a nice day.